Today we're going to do section 9.2, Arithmetic Sequences, which is actually, we already did this in section 9.1, okay? Apparently the author don't notice that he already said it, so I guess we'll do it again, wouldn't hurt nothing. And so it's going to be a fairly short section. The example 1 on page 901, let's look at it. It says, what is an arithmetic sequence? Arithmetic sequence just means numbers that go up by a set amount, such as the numbers. Let's say if we have a sequence of say 2, 4, 6, 8. See, the difference is the same each step. Then it will be an arithmetic sequence. Another example will be -1, -5. -1, -5, and then -9, and then each time you subtract by 4, see, and then -13, etc. That would be another example. So there is really not much to it. So example 1, they want you to look at these two sequences, A and B, and see if the sequences are arithmetic. So please do that yourself, okay? And then let's turn to example 2, which says that if you have the difference of the arithmetic sequence and you are given the very first number, which is say 17, and the difference is -3, that means you take 17 plus -3, that's your second term, then plus -3 again, the third term. So 17, the second term will be, the first term will be 17, the second term will be 17 plus -3, which is 14, and then 14 plus -3, which is 11, etc. So please do example 2 yourself, okay? And let's flip the page to example 3. Now, right before example 3, we are giving the formula for the arithmetic sequence, and that is what we need, which we were not given in the previous section. But we were expected to do the stuff anyway. But now we actually have the formula for it. And the formula is quite simple, see? That is an, the nth term is the first one, and plus, let me write down plus here. The first one plus n minus 1, okay, times the difference. This represents all arithmetic sequences. For example, let's look at this sequence that I just made up. Then this will be the A1, okay? 1, 2, 3, 4. Now the A4 then, according to this formula, A4 will be equal to A1 plus the 4 minus 1, the difference being +2, okay? So does it equal to that? And you have 2 plus 3 times 2, 6, 8, which is 8, and that is correct, see? That it works out. So here's the general formula for any kind of arithmetic sequence. So knowing that, let's look at example 3, okay? It says that if we have A1 equals to 8 and A4 is 14, so I'll write that down. A1 equals to 8 and A4 equal to 14, okay? We need to figure out what A5 is. A5 is what? So then the way we do this is, we first figure out what D is. Once we figure out what D is, then we can plug in A5. So we plug this information, these two pieces of information into the general formula. So then AN, which is in this case A4, which is 14, okay, equal to A1, which is 8, plus N is equal to 4. So 4 minus 1 times D, the difference is, we don't know what, that's what we're looking for. We're looking for D. So notice that this is a equation that we can solve for D. And then by solving for D, let's see. Yeah, it's fine. So let's solve for D. So move the A over there. 14 minus 8, that's 6. Okay, divided by 4 minus 1 is 3. That should be equal to D, and that is 2. So the difference is 2, which means that now we need A5. So following the formula right here, A5 in which case n equals to 5, okay, equals to a1, which is still 8. 8 plus a1 plus 5 minus 1d. And that 5 and d we already figured out equal to 2, so I'll write that instead. So d equals to 2, and let's see, d equals to 2, and then let's calculate this. 8 plus 2 times what? 8. 4 is also 8, so a5 should be 16. And so find a5. Yep, it says a5 is 16, so that is correct. So next, let's look at page 905, where we have an example here. Here is the equation stays the same. This is the general equation of the arithmetic sequence that we have learned. That is, an is a1 plus d times n minus 1. Now, in this example here, if you were to plot each thing out, okay, like n is on the x-axis, whereas an is on the y-axis, if the sequence is arithmetic, you will notice that they will always form a straight line, and that's because it's a linear relationship. And in fact, the number d here is the slope of the line that you are plotting. Anyway, so that's that. So next, let's look at the following page, where we have look at this arithmetic sequence, and then let's write a formula for it, which is something we have done in the previous section, but we'll do it again. So let's look at example 5. All right, so I wrote down example 5. Okay, page 906. The problem says we're giving a sequence of numbers, but we know that it start at 2 and then go to 12, etc. But we know that this is an arithmetic sequence, so we don't need to know anything past 2 and 12. Okay, this is all we know. And then notice what the difference is. The difference is increasing. So d is 12 minus 2 is 10. Okay, that is d equals to positive 10. In that case, we can write down the formula for this sequence right away. an is equal to 2, which is a1, plus n minus 1 times 10. That is the formula. And we can simplify a little bit, I guess, but that's basically it. And that's the answer to example 5. And the reason we don't need anything else, because once we know it's arithmetic, we know what everything else is afterwards by using this formula. You just plug in n, and then each number n equals to 1, 2, 3, it all pop out, see? And so that is example 5. And of course, if you were to plot it on the graph, it will be dots on a straight line, okay? You can join them all with one straight line. And that's example 5. The next, let's look at the next example. Find the number of terms in a bunch of sequences. Okay, so that is a slight twist. We didn't do this last time. Okay, so let's look at example 6. All right, so now we have, this is a1, okay? So a1 equals to 8, and what's the difference? The d is 1 minus 8, okay? The difference is also always the final minus the initial. So d is 1 minus 8, which is negative 7. So let's write down the formula. Then an equals to, in this case, we're trying to figure out this one, okay? So negative 41, which is an, equals the initial term, 8, plus n minus 1, following the formula here, plus n minus 1 times the difference is negative 7. Now this equation right here will give us what n is for the an equals to 41. We need to know what n is. So this is an equals to minus 41. We need to figure out what n is, so this equation will give it to us. Okay, so let's say move the 8 over here. It becomes minus 41 minus 8. And then that equals to n times minus 7. That's negative 7. And plus 7. Okay, and so solve this simple equation. We have well, let me let me just use the calculator. Why don't we? Yeah, I think it, but first probably should not. Let's use the calculator and call it that. First, let me dig out the calculator. Okay, I found that if I use the calculator, I tend not to make as many mistakes. So I stand next to camera, and then we'll do minus 41 minus 8. That's minus 49. 49, and then minus 7. Okay, move the 7 over, and then I forgot to do the parentheses, so I put the parentheses in. Very important, because we have to do a division. Divided by, okay, so all the numbers moved over, then we divide by negative 7. All right, so that's just 8. All right. So that is, did I say 8? Yeah, I said 8. So what do we do? Oh yeah, n equals to 8. Now remember, n has to be a whole number. That is a positive number. If it's a decimal point, you calculated something wrong, or something is wrong about it. So n equals 8 is the answer to this problem, and this example 6. And that's what the book says as well. And then let's look at example 7, which says a 5-year-old child receives an allowance of $1 a week, and then he has an annual increase of $2 a week. So what do we need? We need to write down the formula. When the kid is we'll start out as let me think. All right. So anyway, so let's consider that the 5-year-old child receives the first allowance he gets is when he is 1. Okay, and then the second time, he gets $1 when he is 5 years old. Okay, and then it goes up to each year it increases by 2. So D equals to 2. So the following year, when he's 6 years old, he will have $3. And then eventually, then we need to come up with a formula for this thing. So then AN, then if we call this the first year, okay, that he gets his allowance, and N equals to 1, all right, and then etc. So let's figure out what AN is. So AN, according to the formula right here, is equal to A1, which is 1, the first year, and then plus N minus 1 times the difference. Difference is what? $2? Yeah, I think I'll just write that down. The difference is $2. So here, that's the formula. So then, the question is, so here's our formula, which can be simplified somewhat. And then the question, however, is, let's see. Wait a second. Actually, for this problem, they want to use a different formula, only slightly different. That is, right on top, right before the problem, there is the different formula which is AN equals to A0 plus DN. And so I suppose since it works the same way, I'm not sure why we even care about that, but since the book mentions it, I guess we will do that. Okay, so let's do the slightly different formula which starts at A0. Doesn't matter where you start, and all the formulas work out the same way. A0 plus Dn. Okay, this formula looks shorter. That is A0 now is the first term. So then we will call this thing. So the first year will be called A0. And then the second year will be 1 year after the first year, and we'll call it A1. And that's how, well, anyway, you get the idea. So then following this new formula, so then we have AN, then the formula goes equals to A0, which is 1, plus D is positive 2 times N. That's about it. Okay, so now that we have the formula, the question is, when will the child's allowance be when he's 16? He is now 5, okay? So what you do is, the n is start counting in the second spot. So when he's 16, you'll take, for example, when he's 6, then n will be equal to 1, okay? Because n is counted as 1 year after 5. So 16 will be 16 minus 5. That will be 11. N equal to, when he's 16, means n equals to 11th year. That, because that's the 11th year that he has since he began to get his allowance. The same way that when he's 6 years old, then it's been 1 year since he started getting allowance. So if n is 11, you plug in the 11 here, then an is 2 times 11 plus 1. That would be 22 plus 1 is $23 per week, I guess. Okay, so that would be the child's allowance. So this is the end of this section, I guess. So for homework, please do on page 908, problems 17, 21, 25, 27, 29, 43, 53, and 69. And they shouldn't take too long to do, okay? And because this is a relaxing section. So please do that, and then when you're done, I want to talk about some of them. All right, now that you're done with homework, let's consider problem 21. We have, first let me find a better marker. All right, for problem 21, we have A8 is 40 and A23 is 115. We need to find what A1 is out of this formula right here. So let's do that. First, we will write it down as, well, like this. We don't know what the A1 is, and we also don't know what the difference is. However, we do know these numbers, okay? The 8th term is 40 and the 23rd term is 115. So we can work things out. So first, let's figure out, follow this formula, okay? We have A8, when n equals to 8, so I'll write that down. When n equals to 8, then A8, which is 40, filling in this formula right here, 40 equals to A1, we don't know what that is, plus n is 8, okay, 8 minus 1 is 7, times d. We don't know what d is. So we have two unknowns in this equation. And then, so the next thing, we do the same thing here, and then when n equals to 23, n equals to 23, we have A23 is 115, 115, equals to A1, again, we don't know what that is, but we'll find it. And this is a plus n minus 1, that n is 23, so it becomes 22 times d. All right, so now we have this thing right here. We have, you recognize what this is? This is two equations with two unknowns, okay? So let's do that. This is equation 1, and this is equation 2. So let's take, being that A1 is in both slots, let's take equation 1 minus equation 2. That will give us something without A1. A1 will get subtracted out. So 40 minus 115, that should be negative 75. And that equals to A1 disappeared. And then 7 minus 22 equals to negative 15, d. Okay, and that gives us d equals to 5, right? Because 5 times 15 is 75, taking care of the negative signs. So d should be 5, which means that, so we got d equal to 5. We can plug it into equation 1 and to figure out what A1 is. So from equation 1, we get 40 equals to A1 plus 7 times d, which is 5. And so then A1 would be equals to 35, okay? This is 35, so A1 should be 5. So A1 is also 5, and D is 5, and that should be our answer. So let me check to make sure I'm right. The answer says that A1 does equal to 5, doesn't care what D is, I guess. Yeah, because they only asked for A1, so we got that done. Next, let's look at problem 53. We have A equals to 3, negative 4, blah, 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 all the way to negative 60. The question is, how many terms are in here? Okay, so there's more numbers given, but we don't need it. Okay, we only need 2 of them because we need to know what the difference is. The difference is the final minus the initial, which is negative 4 minus 3. So the difference is negative 7. So so then let's follow this formula right here. Therefore, the formula says an equals to a1, which is 3, plus n minus 1, okay, n minus 1 times negative 7. That is our formula. Specifically, now we're trying to find out what value n is when an equals to negative 60. So we'll write this over here. An should be, we want it to be negative 60 to figure out what n is, okay, when an equals to negative 60. So we just solve this basic equation, and that should do it. So we have minus 60 over here, move the 3 over here, minus 3, okay. This becomes a plus 7, and moved over here is minus 7, and then that is equal to n. And that, I think that's it. So we need to figure out what this is. That should be negative, and no, this is negative, sorry. I was paying too little attention. It's not n, it's negative 7n, right? So otherwise this is not going to make sense. Okay, negative 7n, and this side equals to negative 70, which means n equals to 10. So there are a total of 10 terms in this finite sequence. It's finite because it stopped right there, okay? It's, yeah, it can keep going, but we decided we wanted to stop. So that's problem 53. So next, let's consider problem 69, where we have an unusual situation. Okay, so far we've only worked at numbers, but this time it has a bunch of symbols. Now what? And that changes nothing. We're going to do it exactly the way we did it before. Okay, this is following this formula right here. What are we doing here? We're supposed to find A11. All right, so that's what we're shooting for, is A11. Now, first, notice that there's an A here and there's an A here. These two are not related, okay? It's like two guys whose name are both John, but they're not related. They're totally different. Anyway, so this A is different from that A and has nothing to do with it. So A1 is this whole thing, okay? And A2 is this whole thing, and so on. So what is the difference between these two things? The difference is this term minus this term. What is this minus this? So then we have, if we have this minus this, gives us the difference. The difference is A minus 3A, that's negative 2A, okay? And then 2B minus negative 2B, that's 2B plus 2B, is equal to 4B. That is, if we take A1, okay, this whole thing added to this one is going to be equal to that. And then we take this added to this, it better be equal to that, and it does. Okay, if you add it quickly in your head or something, and you notice this thing added to this is equal to that thing. So that means our difference is correct. And then we'll follow exactly this formula right here, which says AN, in this case is A11, is what we're looking for. AN is A11 is equal to A1, which is that thing. We'll write that down, 3A minus 2B, and then plus n minus 1, and n is 11, so 11 minus 1, okay? I'll write it down, 11 minus 1, and the difference is that thing right there, and we'll copy that down as well, which is minus 2a, and then plus 4b. My marker is getting thinner for some reason. I'm holding it wrong. Okay, so then, so now we just need to simplify this thing, and we're home free. So let's simplify that. So 11 minus 1, that's 10. And then, well, I guess I'll just write it out. So we have 3a. We'll first do the a's. 3a plus 10 times minus 2 is minus 20. So that's minus 3a minus 20a. Yeah. And then the b's, well, I have minus 2b. And then right here, 10 times 4 plus 4 is plus 40, plus 40b. So the total becomes A11, which is what we're shooting for, is 3a minus 20a. That means 17a. And then minus 2b plus 40, that's plus 38b. And if I didn't make a mistake in here somewhere, that should be the right answer. So let me check. What is this? Problem 69. Let's see. Got to find it. Where's it? Minus 17a. Where's my minus? I'm missing the minus. Okay, 3a minus, that is negative 17. Negative 17a and plus 38b, that is correct. Okay, and that marks the end of this section.